Another roadside bomb along a dangerous stretch of highway. IED attacks leaving U.S. forces devastated. IEDs now one of the biggest threats to U.S. troops.
IEDs was something that was targeting a weakness of the U.S. Defense Department. We didn't have a way to combat the IED and how they were hiding them.
The military started to come up with ideas about putting larger arrays of cameras in the sky.
Digital SLR cameras that were being strapped to aircraft in order to provide some kind of awareness, but it really wasn't a solution that they were providing. They were providing just the camera piece of it.
Then they came to us to try and get a more permanent military solution that really had the performance that they needed and would be reliable.
The airborne wide-area persistent surveillance was one of BAE Systems' first solutions towards competing against terrorists utilizing IEDs in the war on terror.
It allowed a wide view, a city-sized view of the area on the ground, and it provided
a forensic analysis for the warfighter so they can identify where IEDs were hidden, where they exploded, and where the root cause of the perpetrators came from.
And it included both visible and nighttime imagings.
As you transition from the early 2000s in the war on terror, operating into contested environment was critical, and the Gorgon Stare program
really set the bar for resolution. They were able to track things over the target area in a much more efficient manner and be able to track objects of interest that were smaller than what the typical other wide area sensors were able to do.
So we took the initial technology that was developed on the DARPA program and transitioned that into the production program for Gorgon Stare.
The biggest advancement on Gorgon Stare was the sheer number of pixels and the resolution that the system was able to provide.
Where instead of taking one large focal plane, they took small cell phone cameras, built them into an array of sensors, and packaged that into a turret to go on an
unmanned aircraft, the MQ-9 Reaper, which allowed it to have very long persistent times in the air.
By providing the level of data that we provide with that sensor, we're providing cutting-edge technology and intelligence for the warfighter so that they can make decisions not only for today's mission, but for tomorrow's mission to keep warfighters safe. The battle space is changing from the war on terror, in which we owned the environment and we had a distinct technology advantage, to the near-peer threat, where we're competing against countries with greater capabilities and greater technologies.
Now we need to be able to have sensors that be able to stand off at much longer ranges and look further without being able to be detected by the adversary.
The next generation wide-area motion imagery sensor that we're designing is the first of its kind that's designed with the use of artificial intelligence. And what that allows the warfighter to do is to make quicker decisions and make more decisions with the data that they're being provided.
We are using really adaptable methodologies for designing our product. We are agile in thought, agile in design, and agile in the way we execute the program.
I feel like we're designing a sensor now that really wasn't even conceived until a few years ago, because no one had ever thought about combining the ability to do long standoff with the ability to do video over a wide area. So we're combining 3 different sensors into one now to create a whole new capability for the warfighter.
As a young submarine officer, listening to other people's stories of people that are in the military and coming to BAE Systems and seeing the benefit of a technology that we're providing to the warfighter and be able to design products that not only provide a competitive advantage, but keep people safe, just like I needed, is important to me, and I know it's important to the men and women in the field.